one day comes up with this whole notion called fractals. I mean, it just came to him. There was no precursor in mathematics to fractals. No such animal. Okay, it just popped into his head. Well, look at his formula. Z, not equals, but comes to and goes from z squared plus c. C means that it happens instantaneously. And what it means is that you have boundedness and unboundedness that instantaneously, in 3 dimensions and time, feed back to each other until the noise threshold is breached, and then it becomes unbounded and becomes an expression. The thing that's wonderful about a fractal is that it has self-similarity at every scale. And everything in nature is fractal. Absolutely everything. In point of fact, the fractal is the physical record of the evolution of a self-organizing, open, complex system. And it has a specific coupling with holograms. It is the local linear expression of a holographic dynamic. That's what fractals are. You won't find that in anybody's textbook, but wait till you see this. We'll go through the rest of this stuff. You know the Fibonacci numbers. Okay? 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. Fibonacci numbers. It's the only number series in the world where the series 1.618 blah 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 as a subset 1 over is 0.618 blah blah blah. That's the only place in the world where it happens. And the golden mean then says some things about, come on baby, when you map it in 2-dimensional frames, what you get is a 2-dimensional fractal. Every expression in the graph is self-similar at every scale to every other expression in the graph. It's a fractal. And when you map it, that's what you get. I want you to remember that shape. When you graph it in its logarithmic relationship, that's what you get.
Didn't work.
Didn't work? Come on, baby. There you go. Now,
it's like some crop circles.
it looks like a lot of things, partner. And what I want you to know about this is that when we talk about self-organizing criticality at all the scales as one of the fundamental defining dynamics that operates across the cosmos, from the finest to the greatest scales, that function operates at the heart of it everywhere. At the heart of it everywhere, because it's archetypal, and we see this archetypal shape everywhere in nature at every scale. We see it everywhere. And there it is, M51. Okay, that's as big as you need to get. And the Fibonacci relationships do what Whittaker said. The masses roll down to the wells and aggregate in these spirals just like they're supposed to. That's exactly what his differential equation says they have to do. But they take the shape of the Fibonacci series. And we see it everywhere. All right. So here's this roadmap that we're talking about. There are simple, elegant rules that operate throughout nature, from the finest scales to the largest. And this is what we think they are. This combination of things we think operate at every scale without exception. The first is this business of punctuated equilibrium. Things go along, go along, go along, and then all of a sudden something happens in a small, bigger, larger, much bigger way all at once. It's not a slow, gradual wind-up. It's equilibrium and then wacko, something big happens. And the experimental verification of this, repeated 10,000 times under controlled conditions, is the construction of a sand pile out of uniform grains of sand. So you drop grains of sand, you drop grains of sand, we've played this game, you build a sand pile, you put a stick in it, and you scoop away. You scoop away, you never know which scoop's going to drop the whole thing, right? That's the kids' game on the beach. Well, in scientific terms, what happens is that you sand, 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 up until a very special point, it's just an aggregation of individual grains of sand. But there comes a point at which this aggregation of sand grains becomes a system. And in that system, interesting dynamics happen. Eventually, you're going to have it avalanche off. And what we now know about that avalanche is that you can't predict when it will happen. You cannot predict where it will happen. You cannot predict how big it will happen. And you can't predict how often it will happen. And that's true for every self-organizing, complex, open system in the cosmos. Earthquakes, the weather, the rises and falls of the stock market, they all fit in the same category. You cannot predict anything that these laws prohibit. What you can do is say mass extinctions over time, 2.5 billion years. For every mass extinction event that measured this magnitude, there will be a logarithmic number of smaller or larger events. So that if you take the logarithmic relationship between frequency mappings, or magnitude mappings, or periodic mappings, what you'll discover is that you get a straight line with a slope. So when you map any kind of data, and you get a straight line with a slope, you know for sure what you're mapping is the logarithmic relationship of a complex, open, self-organizing system. And that's a pretty important piece of information, because those power laws then say that what happens with the way this organizes is that all the geometries that result from those physical events are fractal. Not just the catastrophic avalanches, but the self-sustained criticality that creates a brand new thing. And they operate contemporaneously. And in order for that record to be created, we have quantum functions. You have to breach quantum noise thresholds. This much the standard models got right. It is a quantum universe. You can push that stone as long and hard as you want. You can drop dead trying, but if you don't hit that mark and push it with enough force, it ain't going to move. Okay? As that only stretches just so far, but the point is that we do live in a quantum universe. And there's nothing in between, but what the fractal does is describe what happened between the events by connecting them. By connecting them, because it operates logarithmically. And it's not a fraction, it's a fractal. It's parts of a fraction in between functions. It's the magic stuff. All right, so you take these pieces, you connect them with the Fibonacci numbers, whatever gets organized, whatever collapses, whatever happens in these open systems is then defined by Fibonacci relationships. It takes a certain shape. It has a certain kind of distribution. It has certain kinds of archetypal forms. And we recognize those. Then the vector magnetic potentials come into play. And they operate from the 0 point. Albert got that part right. He didn't get it when he was saying it, but he got that part right. That the vector magnetic potential operates from the 0 point, which is the interface from the physical vacuum to the first stage of integration of undifferentiated information that begins to display duality. Because in the